The morning of June 7, 1944, Rechlin-Lärz airfield, Mecklenburg, Germany. Oberingenieur Hermann Wurster stood in the examination hangar, his engineering notebook open to a fresh page, as ground crews wheeled a damaged American fighter into position under the overhead lights. The aircraft bore fresh scars from its forced landing near Cambrai, France, the day after the Allied invasion began. Its olive drab paint was scorched in places, the right wingtip crumpled, but the fuselage remained largely intact. This was the third North American P-51 Mustang to arrive at Rechlin for technical evaluation in as many months. The first had come in March, shortly after American fighters had appeared over Berlin for the first time in history. The second arrived in April. Now this one, captured within hours of the Normandy landings, represented the most recent production standard of the aircraft that was fundamentally altering the balance of air power over the Reich. Wurster had worked at Erprobungsstelle Rechlin, the Luftwaffe's primary testing and evaluation center, since 1939. He had examined captured Spitfires after the Battle of Britain, studied P-47 Thunderbolts recovered from crash sites in Germany, and tested P-38 Lightnings retrieved from occupied territories. Each examination provided valuable intelligence about Allied capabilities. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But none had presented quite the same puzzle as the Mustang. The problem was not the aircraft's performance. German test pilots who had flown captured examples reported that the Mustang handled well, with light controls and good visibility. Its Packard-built Merlin engine provided excellent power at high altitude, where it outperformed both the Messerschmitt Bf 109 and Focke-Wulf 190 above 20,000 feet. These were concerning developments, certainly, but they represented incremental improvements in aerodynamics and power plant engineering. The real problem was the range. American single-engine fighters were operating deep over Germany, with enough fuel to engage in extended combat, then return to England. This should not have been possible. German intelligence had calculated the operational radius of enemy fighters based on known fuel capacities and consumption rates. The P-47 Thunderbolt could reach approximately 375 miles from English bases with standard drop tanks. The P-38 Lightning could extend slightly further. Both fell short of Berlin by over 100 miles. Yet on March 4, 1944, P-51 Mustangs had escorted bombers all the way to Berlin and back. The round-trip distance exceeded 1,100 miles. 2 days later, on March 6, over 150 Mustangs repeated the mission, this time engaging Luftwaffe interceptors in prolonged combat over the capital before flying home. Combat reports from German pilots indicated the American fighters showed no signs of fuel conservation. They maneuvered aggressively, used full power settings, and departed only when ammunition was exhausted, not when fuel ran low. General Major Adolf Galland, General der Jagdflieger and one of Germany's most successful fighter aces, had flown unauthorized interception missions during this period, despite his administrative position. His combat reports, filed through official channels, noted specific observations about Mustang tactics that contradicted German assumptions. The American fighters operated at full combat capability over Berlin. They engaged aggressively. They demonstrated no apparent range limitations. Galland's assessments carried weight. With over 100 victories and extensive combat experience spanning from the Spanish Civil War through the Battle of Britain and beyond, he understood fighter operations intimately. If he reported that American fighters had fuel reserves over Berlin, German technical staff needed to understand how this was possible. The initial examination of the first captured Mustang in March had focused on measuring internal fuel capacity. The evaluation team at Rechlin worked methodically, documenting every aspect of the aircraft's fuel system. The P-51B variant featured 2 wing tanks, each holding 92 gallons of aviation fuel. Total wing capacity, 184 gallons. The fuselage contained an additional tank positioned directly behind the cockpit, a relatively recent addition to the design incorporated during production. This fuselage tank held 85 gallons, combined internal fuel capacity, 269 gallons. German engineers understood the Packard Merlin's fuel consumption characteristics. At economy cruise settings, the engine burned approximately 60 gallons per hour. At normal cruise power, consumption increased to approximately 75 gallons per hour. Combat power settings exceeded 100 gallons per hour. Using these figures, they performed range calculations. With 269 gallons of internal fuel and consumption of approximately 70 gallons per hour at cruise settings, the P-51B could fly for roughly 3.8 hours. At the aircraft's cruising speed of approximately 300 miles per hour, this yielded a maximum range of 1,140 miles. This matched the distance from English bases to Berlin and back, but only barely. The problem was combat operations. The March missions had involved extended dogfights over Berlin. German pilots reported engagement durations ranging from 15 to 20 minutes before American fighters disengaged. Combat power settings consumed fuel at rates exceeding 100 gallons per hour. 20 minutes of combat would consume approximately 33 gallons of fuel. This expenditure should have left Mustangs unable to complete the return journey to England, yet they were returning safely. The calculations indicated something was missing. From the analysis, Wurster and his colleagues knew about external drop tanks. Every air force used them. German fighters had employed drop tanks since the Battle of Britain. The Bf-109 could carry a 300-litre drop tank. The FW-190 regularly used them for extended range missions. Drop tanks allowed aircraft to carry additional fuel externally, then jettison the empty tanks before combat to reduce weight and drag. This was standard practice. The question was not whether Americans were using drop tanks, but rather what capacity these tanks possessed and how they were producing them in sufficient quantities to maintain operational tempo. A 75-gallon drop tank under each wing would add 150 gallons to the Mustang's fuel load, bringing total capacity to 419 gallons. This would explain the Berlin missions mathematically. But German intelligence had not recovered any 75-gallon tanks from recent crash sites. The search intensified. Intelligence officers plotted likely jettison points based on engagement locations reported by Luftwaffe pilots. Drop tanks would typically be released when enemy fighters were encountered, as the external stores reduced maneuverability and speed. Search teams composed of Wehrmacht personnel and Hitler Youth volunteers spread across the countryside northeast of Berlin, looking for debris from the March air battles. Within 3 days, several objects were recovered from fields and forests in the region. Most were fragmentary, crushed on impact or damaged by the fall. Agricultural workers had found some pieces while preparing fields for spring planting. Others turned up in forest clearings where they had fallen through tree branches. 2 examples arrived at Rechlin in relatively intact condition, having landed in soft soil that cushioned their impact. What Wurster saw when he examined these recovered tanks fundamentally altered his understanding of American industrial methods. The tanks were cylindrical, measuring approximately 108 inches in length, with a diameter of roughly 22 inches at the widest point. Preliminary capacity calculations indicated each tank held approximately 108 US gallons. 2 such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity to 485 gallons. With 485 gallons of fuel, the Mustang could fly for approximately 6.5 hours at cruise settings. This yielded a maximum range of approximately 1,950 miles. Berlin missions would consume less than 60% of available fuel, leaving substantial reserves for combat operations and navigation contingencies. The mathematics finally matched observed combat behavior, but it was the construction of these tanks that proved most revealing. Wurster had expected metal, either steel or aluminum. German drop tanks were fabricated from sheet metal, welded or riveted together, with internal baffles to prevent fuel sloshing. These captured American tanks were made from paper, not simple cardboard, but laminated craft paper, impregnated with resin. Multiple layers of craft paper had been bonded together with what appeared to be phenolic resin, shaped over forms, then coated with fuel-resistant lacquer. The tanks felt surprisingly rigid when empty, maintaining their cylindrical shape without internal supports. Close examination revealed three main components: a nose cone, tail cone, and cylindrical body. Each section showed careful construction, with overlapping layers of paper built up to achieve structural strength. The weight difference was significant. A comparable metal drop tank weighed approximately 150 pounds empty. These paper tanks weighed approximately 50 pounds. That 100-pound weight savings translated directly into additional fuel capacity and range. For the same total weight, an aircraft could carry significantly more usable fuel in paper tanks than in metal ones. Wurster requested a structural test. Engineers at Rechlin subjected one of the captured tanks to pressure testing to determine its operational limits. The tank withstood 6 pounds per square inch of internal pressure without failure or leakage. This exceeded the pressure requirements for normal flight operations. Temperature testing revealed the tanks functioned across the full range of operational altitudes and ambient temperatures, from sea level to 40,000 feet, in temperatures ranging from -60 degrees Fahrenheit to positive 120 degrees Fahrenheit. The technical evaluation documented construction methods, material specifications, and manufacturing techniques. The paper appeared to be standard kraft paper, the type used in paper mills and packaging industries. The resin was a phenolic compound, similar to materials used in electrical insulators and industrial applications. Neither material was exotic or difficult to obtain. The manufacturing process involved shaping wet paper layers over wooden forms, allowing them to cure, then applying protective coatings. This was fundamentally similar to papier-mâché techniques that had existed for centuries. What distinguished these tanks was not revolutionary technology or exotic materials. It was the systematic application of simple materials to solve a specific problem. The Americans had identified that drop tanks needed to function only once. They did not need to be durable or reusable. They needed to hold fuel for approximately 5 hours, then could be discarded. Paper soaked in resin met these requirements perfectly. The implications extended beyond the immediate technical details. These tanks represented a fundamentally different approach to industrial production. Germany faced critical shortages of aluminum and steel. Every pound of metal was carefully allocated to essential uses. Drop tanks, despite their importance for range extension, competed with aircraft production, ammunition manufacture, and countless other requirements for limited metal supplies. German industry could not produce metal drop tanks in unlimited quantities without affecting other priorities. The Americans had solved this problem by not competing for metal at all. Paper and resin were available in abundant quantities. Paper mills that normally produced newsprint and packaging materials could be converted to drop tank production without affecting aluminum or steel supplies. The tanks could be manufactured by workers with no specialized metalworking skills. Women who had previously worked in paper mills could produce drop tanks using familiar materials and techniques. Wurster compiled his findings into a technical report. The document detailed fuel capacities, range calculations, construction methods, and strategic implications. His analysis concluded that American fighter range exceeded German estimates by approximately 40% when using these paper drop tanks. All targets in Germany now lay within range of escorted bomber formations. The systematic bombing campaign could proceed with fighter protection throughout the entire mission profile. The report circulated through Luftwaffe technical intelligence channels and reached senior leadership, including Gallen's office. For German commanders already struggling with overwhelming Allied numerical superiority, the news that American fighters could now operate anywhere over German territory represented a fundamental shift in strategic calculations. The advantage was not something German industry could quickly counter. It was rooted in access to resources and production capacity that Germany simply did not possess. By early summer 1944, the pattern had become clear. American bomber formations appeared over German targets with fighter escort throughout their missions. Luftwaffe interceptors faced American fighters not just at the edges of German airspace, but over every major industrial center, every synthetic fuel plant, every aircraft production facility. There was no safe zone where German fighters could form up without encountering enemy escorts. There was no target beyond escort range where bomber crews flew unprotected. Production data added further evidence of American industrial capacity. Intelligence estimates suggested American factories were producing thousands of these paper drop tanks monthly. The exact numbers remained uncertain, but the operational evidence was clear. Every P-51 mission employed drop tanks. Every P-47 and P-38 long-range mission used them. The scale of production necessary to sustain this operational tempo defied German industrial experience. A single bomber raid might involve 500 heavy bombers escorted by 200 fighters. If each fighter carried 2 drop tanks, that represented 400 tanks consumed in a single day's operations. Major raids occurred 3 or 4 times per week. Monthly consumption exceeded 5,000 tanks just for 8th Air Force operations in Europe. This did not include operations in the Mediterranean theatre, training requirements, or reserves. German industry, struggling to maintain aircraft production under Allied bombing, could not have manufactured 5,000 metal drop tanks per month without severely disrupting other production priorities. The Americans were doing so using materials that did not compete with aircraft production. This represented more than a technical advantage. It demonstrated industrial capacity operating at a scale Germany could not match. The captured Mustang that Wurster examined in June 1944 provided additional confirmation. This aircraft, shot down on D-Day, represented the latest production standard. Its fuel system matched earlier examples. The wing tanks held 92 gallons each. The fuselage tank contained 85 gallons. Total internal capacity remained 269 gallons. Ground crews recovering the wreckage had found remnants of paper drop tanks at the crash site. These had been damaged beyond useful examination, but their presence confirmed that current operations continued to employ the same fuel extension methods documented in earlier evaluations. By this point in the war, German technical staff understood exactly what they faced. American fighters could reach any target in Germany. They possessed fuel reserves sufficient for extended combat operations. They were supported by industrial production operating at scales German industry could not match. The paper drop tanks, simple as they appeared, symbolized advantages that extended far beyond their immediate function. The tanks demonstrated that American engineering prioritized practical solutions over technical sophistication. A disposable tank made from paper represented an adequate solution to the range problem. It worked reliably for its intended purpose. That it was not durable or reusable was irrelevant, because it did not need those characteristics. This approach, designing solutions that were good enough rather than perfect, enabled faster production and more efficient resource utilization. It demonstrated American access to abundant raw materials. Paper and resin were available in quantities sufficient to produce thousands of tanks monthly without affecting other industries. This abundance contrasted sharply with German resource constraints, where every material allocation involved difficult trade-offs between competing priorities. It demonstrated production capacity operating at unprecedented scales. The ability to manufacture 5,000 or more units monthly of a specialized item, using converted civilian facilities staffed by workers with minimal specialized training, represented industrial organization German planners could not replicate under wartime conditions. And it demonstrated the strategic implications of these combined advantages. When technical capability, resource abundance, and production capacity aligned, the result was operational capabilities that could not be countered by tactical excellence or strategic planning. German fighter pilots, however skilled, could not offset American advantages in numbers, range, and sustained operations tempo. The systematic examination of captured enemy aircraft had become a critical function for Luftwaffe technical intelligence. Each evaluation provided insights into Allied capabilities and production methods. The P-51 Mustang examinations at Rechlin revealed something more fundamental than technical specifications. They revealed the strategic reality underlying Allied success. Industrial capacity, applied systematically to military requirements, created advantages that skill and determination could not overcome. Wurster's reports documented these findings with characteristic German precision. Fuel capacities measured to the gallon, range calculations performed to exact specifications, Construction methods analyzed in detail. The technical accuracy was impeccable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But beneath the professional documentation ran an unavoidable conclusion. The war's outcome was being determined not by tactical engagements or operational planning, but by industrial production operating at scales that rendered German efforts insufficient, regardless of their quality. The morning examination that began with measuring fuel tanks had ended with recognizing strategic realities. The paper cylinders, made from craft paper and resin, represented more than extended fighter range. They represented industrial capacity beyond Germany's ability to match, engineering philosophy that prioritized efficiency over sophistication, and resource availability that enabled optimal solutions rather than desperate substitutions. German engineers at Rechlin understood these implications clearly. Understanding, however, did not provide solutions when the underlying disparities remained beyond their power to change. The intelligence assessments compiled at Rechlin during spring and summer 1944 painted an increasingly dire picture for German air defense planners. Each captured American aircraft, each recovered drop tank, each combat report from Luftwaffe pilots added evidence to a conclusion that German leadership found difficult to accept. The strategic bombing campaign, which had inflicted mounting losses on both sides throughout 1943, had fundamentally shifted in early 1944. The shift was not primarily technological, it was logistical. Major Heinz Nock, flying with Jagdgeschwader 11, recorded his observations in diary entries that captured the psychological impact of facing American fighters over German territory. On March 8, 1944, 4 days after the first Mustang escort to Berlin, he wrote about encountering P-51s near Brunswick. The American fighters did not break off when German interceptors approached. They actively sought combat. They pursued German fighters that attempted to disengage. Their presence over the heart of Germany, 300 miles from English bases, represented something Nock had not believed possible 2 months earlier. Prior to March 1944, Luftwaffe fighter tactics had exploited a critical vulnerability in American bomber operations. Heavy bombers flew in tight formations to concentrate defensive firepower, but they remained vulnerable without fighter escort. P-47 Thunderbolts provided excellent protection within their range, but fuel limitations forced them to turn back before reaching targets deep in Germany. German interceptors waited beyond the Thunderbolt range limit, then attacked bomber formations during the long, unescorted portions of their missions. This tactical approach had produced devastating results during major raids in 1943. On October 14, 1943, during the second raid on Schweinfurt's ball-bearing factories, 60 B-17 flying fortresses were shot down from a force of 291 bombers. Another 17 damaged so severely they had to be scrapped. Total losses exceeded 26% of the attacking force. Such casualty rates were unsustainable. The appearance of long-range fighter escorts fundamentally altered this equation. If American fighters could accompany bombers throughout their missions, German interceptors faced enemy fighters regardless of when or where they engaged. The tactical advantage of waiting beyond escort range disappeared when there was no point beyond escort range. The paper drop tanks enabled this transformation. A P-51 carrying two 108-gallon paper tanks possessed a combat radius exceeding 850 miles. This meant the aircraft could fly 850 miles from base, engage in combat operations, and return home with fuel reserves. Berlin, 580 miles from East Anglia, fell well within this radius. So did every synthetic fuel plant in central Germany, every aircraft factory in the Ruhr, every ball-bearing facility, every transportation hub. German intelligence analysts calculating American fighter coverage discovered that with drop tank-equipped escorts, there was no military or industrial target in Germany beyond reach of protected bomber formations. The systematic targeting of German war production, previously constrained by bomber vulnerability during unescorted flight segments, could now proceed with fighter protection throughout the mission profile. The psychological impact on German fighter pilots proved significant. Oberleutnant Johannes Steinhoff, commander of Jagdgeschwader 77, later described the experience of encountering American fighters over targets that had previously been beyond escort range. The certainty that reinforcements would arrive, that interceptors could form up without harassment, that attacking bombers meant fighting only their defensive guns. All these assumptions had structured German fighter tactics. When American fighters appeared everywhere, these tactical foundations collapsed. Fighter pilot morale, already strained by mounting casualties and diminishing air superiority, deteriorated further. Between January and April 1944, Luftwaffe day fighter forces lost over 1,000 pilots. These losses included experienced squadron, Gruppe, and Geschwader commanders whose tactical expertise and leadership proved irreplaceable. Each American incursion cost approximately 50 Luftwaffe aircrew. The attrition rate exceeded training capacity. Replacement pilots arrived with fewer flight hours and less combat experience than the men they replaced. Gallen's official reports to the Air Ministry during this period documented the crisis with unsparing clarity. In testimony submitted in April 1944, he stated that German fighter forces faced imminent collapse. The combination of numerical inferiority, fuel shortages, replacement pilot quality degradation, and continuous operations tempo created conditions where defeat was mathematically inevitable unless fundamental changes occurred. The paper drop tanks appeared throughout these assessments not as a decisive weapon, but as a symbol of deeper disparities. The tanks themselves were simple devices. Their significance lay in what their mass production revealed about Allied industrial capacity and strategic approach. German engineers examining captured examples understood the technical details perfectly. What they could not change was the industrial reality those details represented. Consider the production requirements. Each paper drop tank required approximately 10 pounds of kraft paper, 3 pounds of phenolic resin, wooden forms for shaping, assembly labor, quality control testing, and protective coating application. Manufacturing time per tank was approximately 4 hours, including curing time. Production cost was estimated at less than $5 per unit compared to over $30 for equivalent metal tanks. A single converted paper mill facility could produce several hundred tanks per week using existing equipment and workers familiar with paper handling. Scaling to thousands of tanks monthly required no exotic materials, no specialized machine tools, no highly trained workers. It required paper, resin, forms, and assembly space. All were available in abundance in American and British industrial infrastructure. Germany could not replicate this approach for multiple reasons. Paper and resin were available, certainly, but Germany's constrained logistics network meant every material allocation involved trade-offs between competing priorities. Converting paper mills to drop tank production meant reducing output of materials needed elsewhere. The systematic Allied bombing of German transportation infrastructure meant distribution of finished tanks from production facilities to operational airfields, presented significant challenges. More fundamentally, Germany did not possess industrial capacity operating at scales where producing thousands of single-use items monthly was sustainable. German industry focused on durability and reusability because replacement production could not keep pace with consumption. Metal drop tanks were reused when recovered, aircraft components were rebuilt and reused, ammunition was carefully rationed. The concept of manufacturing thousands of disposable items that would be used once and discarded represented an approach to resource utilization that German economic constraints did not permit. This illustrated the strategic difference between Allied and German approaches to industrial warfare. The Allies could optimize for efficiency and volume because their production capacity exceeded immediate requirements. Germany had to optimize for conservation and reuse because production capacity fell short of requirements. These were not merely different strategies, they were responses to fundamentally different resource positions. The spring 1944 air campaign demonstrated these disparities in operation. Between March and June 1944, the 8th Air Force flew major bombing missions 3 to 4 times weekly. Each mission involved 400 to 800 heavy bombers, escorted by 200 to 400 fighters. If each fighter carried 2 drop tanks, a single day's operations consumed 800 to 1600 tanks. Over 4 months, total consumption exceeded 50,000 tanks just for 8th Air Force operations in the European theatre. German intelligence compiled these estimates with growing recognition of what they indicated. Producing 50,000 units of any item in 4 months represented industrial organization operating at scales German industry could not match in most categories, let alone for specialized items like drop tanks. The systematic application of this production capacity to military requirements created operational advantages that tactical skill could not overcome. The combat results reflected these advantages. Luftwaffe fighter losses mounted throughout spring 1944 as American escorts engaged German interceptors over defended targets. German pilots who survived multiple encounters with American fighters reported consistent patterns. American formations outnumbered German interceptors, often by ratios exceeding 6-1. American fighters operated aggressively, pursuing German aircraft that attempted to disengage. American pilots demonstrated increasing skill and tactical sophistication, with replacement pilots showing training standards that matched or exceeded those of German veterans. Major Walter Wolfram, a Luftwaffe test pilot who evaluated captured P-51 Mustangs at Rechlin, later described his impressions of the aircraft in interviews with Allied intelligence officers. He noted the Mustang's light controls, good visibility, and docile handling characteristics. The aircraft flew well and performed predictably, but he emphasized that the Mustang's technical capabilities were only part of its impact. What made the Mustang decisive was not its design, but rather the fact that American industry could produce them in quantities sufficient to overwhelm German defenses, while maintaining pilot training programs that produced competent replacements faster than losses occurred. This pattern repeated across multiple aircraft types. American factories produced approximately 15,000 P-51 Mustangs during the war. Production peaked at over 500 aircraft monthly in mid-1944. This represented just one fighter type. P-47 Thunderbolt production exceeded 15,000 units. P-38 Lightning production approached 10,000. Total American fighter production during the war exceeded 90,000 aircraft. German fighter production for all types combined totaled approximately 40,000 aircraft for the entire war. Peak monthly production reached approximately 3,000 fighters in mid-1944, achieved only through massive reorganization of remaining industrial capacity and dispersal of production to underground facilities. These numbers were achieved while under systematic Allied bombing that degraded production facilities, disrupted supply chains, and forced dispersal of manufacturing that reduced efficiency. The paper drop tanks fit within this larger pattern of industrial disparity. They were a small component of Allied air operations, but their mass production at scales German industry could not match illustrated principles that applied across the entire war production effort. When one side possessed industrial capacity sufficient to produce thousands of disposable items monthly without affecting other production priorities, while the other side struggled to maintain production of essential items, the long-term outcome was determined by this fundamental disparity. Galland recognized these implications clearly. In meetings with senior Luftwaffe leadership during summer 1944, he argued that tactical innovations and operational reforms could not overcome the strategic disadvantages Germany faced. The Luftwaffe's fighter force was being systematically destroyed, not through tactical defeat in individual engagements, but through attrition warfare, where American replacement capacity exceeded German losses, while German losses exceeded replacement capacity. He proposed concentrating fighter forces for a single massive strike against American bomber formations, hoping to inflict such severe losses that the bombing campaign would be suspended temporarily. The plan, known as the Big Blow, called for assembling 2,000 fighters for simultaneous attack on a major raid. Galland calculated that such a concentration could destroy 400 bombers in a single day, potentially forcing a reassessment of daylight bombing operations. The plan faced insurmountable obstacles. Assembling 2,000 fighters required suspending operations across all other fronts. Fuel requirements for such a mission exceeded available supplies. Training replacement pilots to execute coordinated attacks at such scale required time Germany did not have. Most critically, even if the plan succeeded and destroyed 400 bombers in a single day, American production capacity could replace those losses within 2 months, while German losses from the operation would take 6 months to replace. Reichsmarschall Hermann Göring, commander of the Luftwaffe, rejected the plan. His reasoning reflected political rather than military considerations. A single catastrophic defeat of American bomber forces might provide temporary propaganda value, but it would not change the trajectory of the war. German leadership understood by mid-1944 that military defeat was probable. The question was not whether Germany could win, but rather how long resistance could continue and what terms might eventually be negotiated. The systematic examination of captured P-51s and their paper-drop tanks continued through summer and fall 1944. Each evaluation added detail to technical understanding without changing strategic conclusions. American fighters could reach any target in Germany. They possessed fuel reserves for extended combat. They operated in overwhelming numbers supported by production capacity Germany could not match. These facts were documented with engineering precision and transmitted through intelligence channels to leadership that understood their implications, but could not alter the fundamental realities they represented. By September 1944, the air war over Germany had reached a decisive phase. The Luftwaffe could still contest individual missions, still inflict casualties on bomber formations, still demonstrate tactical capability in local engagements, but the systematic destruction of German fuel production, transportation infrastructure, and industrial capacity proceeded regardless of these tactical results. The cumulative effect of sustained bombing, enabled by long-range fighter escort made possible in part by paper-drop tanks, degraded German war production faster than it could be replaced or distributed. Fighter production suffered particularly severe effects. Bombing of aircraft factories reduced output. Destruction of ball-bearing facilities affected aircraft assembly. Disruption of transportation networks meant completed aircraft could not reach operational units. Attacks on synthetic fuel plants meant fighters that reached units often lacked fuel for operations. The Luftwaffe fighter force that had numbered over 4,000 aircraft in early 1944 declined to under 2,000 operational aircraft by year's end, not primarily through combat losses, but through systematic destruction of the industrial and logistical infrastructure that sustained operations. The paper-drop tanks served throughout this final phase of the air war. Production continued at thousands of units monthly through 1945. American fighters carried them on missions over Germany until the final days of combat operations in May 1945. British fighters employed them extensively. The tanks proved reliable across all operational conditions. Failure rates remained negligible. The simple technology that German engineers had examined in captured examples in March 1944 continued functioning exactly as designed for the duration of the war. German technical staff maintained documentation of American equipment throughout the war with characteristic professionalism. Reports filed at Rechlin preserved detailed information about P-51 specifications, drop tank construction, fuel consumption data, and operational capabilities. These documents, recovered after the war and archived in facilities including the Bundesarchiv, provide historians with precise contemporary German assessments of Allied equipment. Reading these reports with modern historical perspective reveals that German technical analysis was remarkably accurate. They correctly understood American capabilities. They accurately calculated fuel ranges. They properly assessed the implications of drop tank-equipped fighters for German air defense. What they could not change was the strategic reality those capabilities represented. Understanding that an enemy possesses overwhelming advantages provides no means to counter those advantages when they are rooted in fundamental disparities of industrial capacity and resource availability. The legacy of the P-51 Mustang and its paper-drop tanks extends beyond their immediate wartime use. The aircraft stands as one of the most successful fighter designs in aviation history. Its combination of range, performance, reliability, and producibility made it an ideal escort fighter for the strategic bombing campaign. Over 15,000 were manufactured during the war. The aircraft served in multiple theatres, performed multiple roles, and remained in service with various air forces into the 1980s. The paper drop tanks represented a particular philosophy of engineering design that became influential in post-war systems development. The concept that solutions should be adequate for purpose rather than technically perfect, that disposable components could be more efficient than durable, reusable ones, that manufacturing simplicity could enable production scales impossible with complex designs. These principles informed military and civilian engineering throughout the latter half of the 20th century. The story preserved in German technical reports from Rechlin continues to inform understanding of World War II and industrial warfare. The systematic examination of captured equipment provided German engineers with clear understanding of Allied capabilities. That understanding arrived too late and revealed disparities too fundamental to overcome through tactical adjustment or operational reform. The war's outcome was determined by factors beyond the control of engineers examining paper cylinders in examination hangars. The March 1944 missions to Berlin, the first to be escorted throughout by single-engine fighters, marked the decisive turning point in the air war over Europe. From that date forward, no target in Germany remained beyond the reach of escorted bombers. The systematic campaign proceeded with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, transportation networks, all became targets that could be attacked repeatedly with fighter escort throughout missions. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51s reached Berlin. The paper drop tanks, made from kraft paper and phenolic resin, manufactured in converted paper mills by workers who normally produced newsprint, served throughout this final period. They enabled the range extension necessary for strategic operations while freeing aluminum and steel for other uses. 80 years after these events, the lessons remain instructive. Industrial capacity, applied systematically to military requirements, creates advantages that tactical excellence cannot overcome. The optimization of resources, matching production methods to requirements, prioritizing efficiency over tradition, these approaches characterized Allied operations and contributed fundamentally to victory. The paper drop tanks falling across Germany throughout 1944 and 45 represented more than extended fighter range. They represented industrial capacity, operating at scales that determined the outcome of modern conflicts. The technical files maintained at Rechlin documented American capabilities with professional precision. German engineers recorded specifications, performance data, construction methods, production estimates with thoroughness characteristic of German technical work. These records provide historians with detailed contemporary assessments of Allied equipment as seen through German eyes. Reading them today reveals that German technical staff understood exactly what they faced. That understanding could not change outcomes determined by strategic realities beyond their power to affect. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.